Hi, welcome to this video. In this, we are going to discuss the programmable interval timer, and this is a reference for this topic, and this is under the microprocessor and the microcontroller. Let us move on to the timer. So this is a interrupt time sharing operating system at evenly spaced intervals so that it can switch the programs. So the output precisely timed signals with the programmed periods to an I/O devices. Example, it is a body converter. It serves as a programmable baud rate generator. It measures the time delays between external events. Also, it counts the number of times an event occurs in an external experiment and provides a means of inputting the count to the computer. It causes the processor to be interrupted after a programmed number of external events have occurred. So this 8254 programmable timer interval timer, it is a 3 identical counting circuits: clock, gate input and output, and it controls the status and the register pair. So the CR counter register for receiving the initial count is referred, and the counting element CE is which performs the counting, but it is not accessible, and the output latches OL is used here. And this is a functional block diagram of the 8254, and it is having a data bus buffer and read bar write logic, control word register, counter 0 to 2, and in the counter 0 to 2 it's having a clock gate out and clock gate 1 and out 1 and so on. And in the read bar write logic, very important one, read bar write, and you are having a A0 A1 and a chip select. So this is a functional block diagram of the 8254, and this is a read bar write logic. Okay, so it is having a A1 A0 and a read bar write bar and a chip select. So it is having a 5 signals: read bar, write bar, chip select, and the address lines A0 and A1. So in the peripheral I bar O, the read bar and the write bar signals are connected to the IO or IO write bar respectively. In the memory mapped IO, these are connected to memory read bar and the memory write bar. So the address lines A0 to A1, that is, if the 00 means counter 0, 01 means a counter 1, 10 means counter 2, and 11 means control word register. So this is a very important control word format. Okay, and this address lines A0 A1 of the CPU are usually connected to the lines A0 and A1 of the 8253 or 54, and the chip select is tied to the decode address. Okay, and the control word register and the counters are selected according to the signals on lines A0 and the A1. So already we have discussed these are the format. Okay. So next command type. So there are 2 command type. One is a counter latch command and a read back command. So in the counter latch command, CE is the counter specified by the 2 MSB to be latched into the corresponding outer latch, and the read back command, combination of CE is to be latched, or prepare the combination of status registers to be read. So this is a read back command format. So in the readback command format, it is a third method, uses the readback command. This command allows the user to check the count value, programmed mode, and the current status of the out pin, and the null count flag of the selected counters. Okay, so this is a command format, and here D5, when you go for the D5 and count 0, the count bar, it is if it is equal to 0, latch count of selected counters. When the D4 equal to 0, latch status of the selected counters, that is a status. And D0 to D3, that is if it is equal to D1, D2, D3 are equal to 1, D1, D2, D3 are equal to 1, accordingly the counter 0, counter 1 and counter 2 will be selected, and the D0 will be reserved for the future expansion, and it must be a 0. Okay, so in this way the readback command may be used to latch the multiple counter outputs latches by setting the count bit d5 equal to 0 and selecting the desired counters, and each counter latch count in held until it is read or the counter is reprogrammed. That counter is automatically unlatched when read. Okay, this is a one part of information. Next, very important one. So this is a control word format. Here SC1, SC0 and read bar RW1, RW0 and mode operation, and finally we have a BCD. So one by one we will see. So first one select counter. If it is SC1 and SC0, that is if the 0 0 means we can select the counter 0. Likewise, if it is 1 1 means it is illegal for this operation. If it is 1 0 means select the second counter. If it is 0 1 means select the first counter. Next, what about that is read bar write indicator, that is RW1 and RW0. If it is 0 0 means counter latch command, or if it is 0 1 means very important one, read bar write least significant byte only. If you put 0 1 in this control word, we means we are going to LSB only considered. If you write 1 0 means we are going to MSB must be considered, and if you are writing 1 1 means the least significant byte first and then MSB next. So next one, mode 0 operation. So if M0 to M2, we are going to select accordingly. That is, if the 0 0 0, three things are 0, M0, M1 0, M2 0 means mode 0 will be operated. Likewise, if you go for 1 0 1 means mode 5 is operated. So this is a very important one. After that, finally we have a BCD. So if you put 0 here, we are going to take binary counter 16 bits. If you put 1 here, binary coded decimal counter here for 4 decades. Okay, so likewise it is framed here. So next one, the current status. So this one is out, means the current status of the out pin is readed here. And next, so it indicates the null count. Already we have discussed it. It indicates the null count. So this is a very important to frame the control word for the 8254. Next, we will move on to the mode, different modes of operation. So in this, first mode is mode 0. So interrupt on terminal count. Interrupt, we are going to interrupt to the microprocessor. So interrupt on terminal count. If a gate is equal to, here there are 3 operations: normal operation, gate disable operation and new count operation. If it is a gate is equal to 1, it enables the counting, and if out goes low, when there is an output to the control register and remains low until the count goes to 0. So this is a very important one. Mode 0 is primarily for even counting. Let us see one example. Here I am going to write a counter 0. Consider the count 0 0 0. Mode 0 is 0 0 0. Okay, already we know how to write the frame word, control word format. And here I am writing RW1 RW0 is equal to 0 1, because I am going to write only LSB only. So I am going to consider the 0 1, and the binary counter is equal to 16 bit. So putting all these things in the control word format, I am getting a 1 0. And I am going to count only 4. For example, any number. As if here I am considering a 4. So what happened means, you just zoom into this topic. Here I am writing control word as a 1 0 and LSB equal to 4. So what happened means, initially my out is high. So once the counter starts, automatically it will count, it will go to the minimum value. Once it is 0, again it will go to the maximum value. So in this way the mode 0 operation is executed. So next one, what about your mode 1? When the count reaches 0, out will go high, thus producing a negative going out pulse, n clock pulse for the n clock pulse long. So this is another one, mode 1 operation, hardware re-triggerable one shot. What about your mode 2 means periodic interval timer. So out goes from 1 to 0 when the count becomes 1 and remains low for 1 clock pulse. Then it returns to 1 and the clock, that is CE, is reloaded from CR, thus giving a negative pulse at out after every n clock cycles. If you observe this diagram, you can easily understand. So this is a periodic interval timer. Next is square wave generator. It is similar to mode 2 except that out goes low when half the initial count is reached and remains low until the count becomes 0. What about your mode 4 means software triggered strobe. It is similar to the mode 0 except that out is high while the counting is taking place and produces a 1 clock period negative pulse when the count reaches 0. So that is the difference here. What about the final one is a hardware triggered strobe re-triggerable. So out will be high during the counting but will go low for 1 clock period when the count becomes 0. So gate can reinitialize the counting at any time. So this is a important point when you go for the mode 5. So that's all about your timer. Thank you.